Hey guys, this is Keenan Fry, the Acid Drip, and we're here for the wrap up on the tutorial series for blind and visually impaired folks doing some basic household electric testing, outlet receptacle testing. So I want to once again say, kind of as a bookend, that I'm not an electrician. None of this should be construed as literal advice for you to go out and do this kind of testing yourself or to hold me accountable. If you do decide to go do this kind of testing for yourself, it's not advice. I'm not an electrician. I'm not responsible for your actions. You are accountable for yourself. So everything that was in the series prior to this was just kind of like common sense, basic safety stuff, and then a little bit of some technical things on how GFCIs function, the reset test sort of function, and then of course how you can do basic testing in wall receptacles to make sure that like the GFCI is actually functioning properly. Again, this isn't information on how to pop a GFCI out of the wall and rewire it or anything crazy like that. This is just to tell if it's working properly. So we talked a little bit about how volts are coming out of the outlet, and again the outlet is DC, or is, excuse me, AC. So the outlet is AC alternating current, 120 volts. Now we're going to very briefly talk about volts, amps, and watts. And I have some notes that are going to kind of help me relate this to you. And this is kind of like the garden hose metaphor, okay? So we're going to talk about volts and amps, and then we're going to do the metaphor. So the flow of electrons in a wire is similar to the flow of water in a garden hose, okay? The voltage is the potential difference or pressure that pushes the electrons through the wires, similar to the pressure that would push water through a garden hose. Okay. Amps is the current or flow of electrons in a circuit, like the amount of water going through the hose. So if you have a hose that's being given water, but you have, so let's say you have one of those trigger heads with the gasket on the actual hose. Until you open the gasket by squeezing the handle and opening the hose, there's a level of pressure feeding from the wall into the hose, and it's being blocked by that gasket. So that is the equivalent of volts. It's the potential, it's the pressure, it's the buildup of pressure, it's the potential for water or electrical current to be released. But the amount that's actually in that hose is amperage. So one is pressure and one is amount, okay? So then what ends up happening is you multiply those two together to get watts. So watts, right? I got an amp. I got my main guitar amp. It's a PV6505 Plus. It's a combo, it's a 112, and it is a 50 watt amplifier. So what does that mean? Okay, somehow the combination of volts and amps results in a multiplicity that is determined as 50 watts for that amplifier. Okay, how is that relevant to you? You might have a vacuum cleaner that has 30 watts. Let's say that you look at the cable on that vacuum cleaner and it gives you 10 amps. So if you know the amps and you know the watts, you know you're missing the volts. Okay, if you know the amount of volts you're missing, well, you can divide 30 by 10 and derive that there's 3 volts. Okay, what you want to pay attention to is when a wattage rating is higher than the tolerance of your receptacle, because then you're getting into this weird realm where you might be plugging in an electrical piece of equipment that is going to present itself as being of a higher threshold of capacity. Now, the best example I can give you is that washers and dryers, for example, are one very common household appliance that uses a higher electrical rating than the normal 120. So you need a special outlet and a special line run from your breaker box, your distributor, your power distributor, to the area where you're going to have your washer and dryer. That's like one example. Another one is like refrigerators, like big cooling refrigerators. That's another one that it requires a special receptacle design to meet its tolerances. So here's something that happened a couple years back. I worked at a music festival, and the guy didn't know what he was doing, and he plugged a regular extension cord into a portable refrigerator. And we're not talking like a mini fridge, we're talking about a legitimate like giant storage freezer refrigerator that's basically supposed to go to a direct distributor box that's connected to the generator. So because it wasn't directly connected to the Jenny and it wasn't directly connected to the distributor box, and he was literally daisy chaining it with extension cords, which is like, just like, it was baffling to me that somebody would think that that's safe. What ends up happening is so we were talking about watts and amps and volts, right? So going back, volts is the pressure, right? So if an electrical device demands more current than what is being provided, that means the voltage isn't strong enough, it's going to try and pull more through the cable. But if it pulls more pressure, that means more volts through the cable than the rating of the cable's tolerance, the cable will superheat and start a fire. Okay? So that's really, really, really bloody dangerous, because we were at a music festival. This is borderline criminal negligence. I'm not going to talk about who did this or how it happened, but I'm just going to relate this experience in a sort of vague manner. But the person who was supposed to be managing the electrical did not know what they were doing. And the reason is because the people who were managing the event did not pay the electrician to come out and actually set up the equipment. They cheaped out and they did not actually pay for a licensed electrician to set up their equipment. It was a really weird situation, but it was a very clear example of borderline criminal negligence, because we were in an open grass field and we had this long daisy chain of cables going from a splitter that should have been plugged directly to the distributor box, which is an isolated power source, has its own transformer, has its own breakers, and that is supposed to run from the Jenny generator. And what ended up happening is they just daisy chained it, and they did it from some weird receptacle. It was clearly done by someone who didn't know what they were doing, and we were in a grass field. This is a giant grass field in the middle of summer. It was August, in the middle of a giant grass field. I'm not going to give you any idea of the location, because then it'll help you identify the people who did this. But the point is, it's a big old grass field, and that could have been another campfire. That literally could have been another gigantic, massive fire. So what you need to understand on a basic level is, like, that's not likely to happen to you. That's a very kind of extreme example that happened to me during my time as a contractor doing consulting work and working in press and media. But what I want to explain to you is you should understand basic tolerances for what's going into your receptacle. There are certain things that can be plugged in, there are certain things that can't. You need to understand, like, very basics about electronics to know what the tolerance rating is for what can and can't be plugged in, and you have to understand that there are different receptacles for different appliances. And this is relevant because if you move your house, you're going to have to know what the tolerance is to the new location you're moving to if you move apartments. And, you know, like I said earlier, it's very common for people in cities to live in apartment complexes that have, gets really complicated in an apartment complex. You have an individual breaker board for your room. You usually have a breaker board for either your floor or side of the building. And then you have one that's outside of the building that's for like the entire building, and that's run by PG&E. That's how it generally works in California. It's really complicated with apartments because they have to have isolation and redundancy to protect the residents living in the house. So the point is, in apartment complexes, it gets way more complicated and negotiating with your landlord, like, hey, what's the wiring like? What's the situation like? What's available? What's safe? Has there been renovation? When the renovation was it done up to code? These are really basic comprehension questions that you should be able to ask your landlord as a means of protecting yourself. And, you know, one of the things about blind and low vision individuals is they generally find themselves living in cities because there's more accessible services, there's better transportation, there's a wider accessibility to the community and the environment. It's not always the case that they live there, but generally speaking, more services are available to them there. And because you will find yourself likely living in a city if you are blind and visually impaired, it also means that you're very likely to be living in an apartment complex. So having some understanding of like how an apartment complex, the electrical system is laid out, understanding that if the power goes out, you first have to check your personal box. Then you have to check the box that's either for your side of the building or for your floor, depending on the layout of the apartment complex. And then it could be the entire building being out from the street distributor. And you don't know these things, but you'll be able to figure it out. And that was kind of the intent of this, was to give you a little bit of individual means to understand what's going on, to communicate with people who do know more than you and are capable of actually addressing these issues, but so that you have the comprehension to ask them questions and to advocate for yourself. Because the goal isn't for you to open up your own panel and do your own electrical work. The goal is for you to just understand the basics. So going back to the garden hose metaphor. Okay, we know that voltage is the pressure. So that is the amount of flow going through a cable, and similar to the garden hose, it's the water flowing through the hose. So that's the potential for water to be released. But then the amperage, which is the amount coming through, that's related to, for example, the diameter of a hose or the diameter of a cable. If a cable is bigger, it can have a higher tolerance for a load. It has a higher load tolerance, a higher load threshold. It can power larger electrical devices. Much like the garden hose, if the hose has a wider diameter, it's going to be able to push out more water, okay? So you could technically have two buckets with two garden hoses, okay? And let's imagine that we have a garden hose that has low pressure but a wide diameter, okay? So let's say it has a diameter of 2 inches, but it has a pressure rating of like 5 psi, okay? Then you have a different garden hose, and the other garden hose is narrower. Instead of the 2-inch diameter, it has a 1-inch diameter, but it has 10 psi. So what's going to happen is you turn these two garden hoses from independent water sources, and they're both going to fill the buckets at the same rate. They will transfer water at the same rate into those buckets, okay? And that's kind of what's happening with your electrical. What's going on there is you have an amperage, which is related to the amount of water coming through, and we were talking about that as the diameter. And then you have a voltage, which is the pressure, and we talked about that as psi. And so you have a value of 10 cubic units of water per second, and that's very comparable to what wattage is. Now on the other side of the hose, we had a single 1-inch diameter, which is related to the amps again. So that's the bandwidth of the cable, but that cable is under a higher amount of pressure. It has more stress on it. Now, what that means is the water that's coming through it, it's under a higher pressure, it's moving faster. And so because it's moving at a faster rate, it's going to fill the bucket at the same rate as the larger gauge hose, even though the larger gauge hose is using a lower pressure. And this is going back to that example about the refrigerator that I was talking about in that music festival, where you had a cable that was underrated for the refrigerator, and it was under a ridiculous amount of pressure because there was just a ridiculous amount of voltage being pulled through it, but then also the amps was being put through it at a very high rate that was creating a multiplicity between volts and amps that resulted in a wattage rating that was higher than the tolerance rating of the cable. So what you want to know when you look at cables is, what is the wattage rating? What am I going to be using this with to make sure that your cables don't superheat and start fires? To make sure that your receptacles are up to a certain threshold and can tolerate certain devices being plugged into them. That's how that works. So you have to have different gauge cables, and you have to understand like these basics about ratings. Now most appliances won't have this problem, and generally speaking, people don't unplug washers and dryers, move them around, and then plug them back in somewhere else. You usually have a dedicated space for a washer and dryer because you need that dedicated outlet. But when you do move a washer and dryer, generally the only time it happens is when you're replacing the unit or when you're moving your home or apartment. And that's when it's important to have this basic information, because it gives you the ability to advocate for yourself and ask some questions like, what's the tolerance? And then you can look at your appliance, you can listen to the rating that the homeowner who's selling you the home or the landlord who's renting you the place tells you. And if something doesn't sound right, you can say, hang on, I think I'm going to go call an independent electrician and have them come in. Because usually what happens is these places that are being rented, the landlord has an electrician on call, but it's their buddy who's doing the electrical, and they may not have your best interests at heart because they're on the payroll of the landlord. Similarly speaking, houses go all the time on the marketplace that are being flipped. The contractor who's flipping the house has an electrician in their back pocket that they call up to do these quick slap chop jobs, and it's not always done right. That's what we were talking about earlier with the bootstrapping or the bootlegging. A bootstrap neutral, which is a form of bootlegged wiring. There are many kinds of bootlegged wiring, but a bootstrap neutral is two neutrals that should be isolated that are sharing a singular line that is creating a backfeed, which can shock you. And then, you know, there's many other things that can happen. So just, I know that this was a very sort of comprehensive explanation for a lot of things, but it actually is more general based knowledge than it seems. But it seems like a lot, but it's not. It's some basic safety stuff. It's some basic general information. I'm going to cut it there and just say thank you for watching. Thank you for putting up with me ranting through this whole series. I hope it was helpful for you. I hope the garden hose metaphor helps you understand how volts, amps relate to watts, how two hoses that are different can fill a bucket at the same time, the same way cables can transmit an electrical charge. And of course, talking about the Klein tool, talking about the voltmeter, and then cable technique and so forth. This is my first sort of series on blind and visual impairments. I mentioned earlier that I want to do some stuff on cane technique, and I'm going to try and get fitted for a cane hopefully this summer so that I can begin messing around with cane technique and get better at it, and then maybe sometime towards the end of the summer when I've developed more competency with cane technique, I might actually do some demonstration videos. But that's neither here nor there. That's later on. So once again, I'm Keenan Fry. This is the Acid Drip. Thank you for watching, and I'll see you next time. Bloopers, parts 1 and 2. Giggity. Damn. Audio sync. Hey there, I'm Keenan Fry, and this is the Acid Drip. Oh, that's a blooper. Damn. Oh, it burned my nostrils. Damn. Whew. Okay, audio sync. Visit theaciddrip.com for more content.